You're listening to a V-Exchange podcast.
Welcome to the V-Exchange podcast series. I'm your host, Benjamin Hunting, and today we're talking about the Internet of Things and trends relating to it that will increasingly call for colocation data centers and cloud services to play a major role. With us is Sara Rauchwerger, founder and managing director of TechLAB Innovation Center. Thank you for being here today, Sara.
Thank you very much for inviting me.
Now, connected cars are something that's very much in the news on an almost constant basis these days. And I think what sometimes get lost in the discussion of autonomous vehicles is the sheer amount of data that's going to need to be transmitted in order for the connected landscape to function. And not just from vehicles, but also traffic lights, signals, and sensors on almost every mile of roadway. How is it going to be possible to manage all of this data?
That's a very good question. Well, amazingly, living in Silicon Valley has changed so much. I've had a podcast with you guys last year, and what we see at TechLAB Innovation Center, which is a tech startup center, are pieces of the future. Our topic today is autonomous vehicle, which has taken center stage, even though that vision is more than 60 years old, but has been in the works for more than 20 years recently, really thanks to DARPA. But if you go back 60 years, we didn't really have the technology. Even 20 years ago, we really didn't have that technology. It's become much more sophisticated. So now we could actually start to leverage on it. Over the past year, just at TechLAB at our center, there's a company called TerraDeep. It's an early stage rising kind of startup and is resident. They've been developing what's called a deep learning software and hardware solution, which is basically the principle of the whole autonomous vehicle. So I've been watching how a machine learned to recognize things as silly as a cat, a dog versus a human, all in real time. To then, funny enough, a year later, have Detroit knock on our doors to want to buy the solution from them. You're probably starting to understand the correlation. What's happening in the industry is that more and more applications are being built for real-time feed of information, collecting enormous amount of data. To manage all this data, we've been kind of building open platforms that have been helping facilitate easier adoption. But the key component to make all of this work is really analytics. It's helping building what I consider the ecosystem or the peripheral products and services that will support this new industry. For example, the whole autonomous vehicle, you need to have a detailed mapping which shows your vehicle routes. The vehicle has to make the right decision, traffic signal, communication, sensor technology. A lot of the sensor technology is part of the IoT, and I know you mentioned that at the beginning. Amazingly enough, at Silicon Valley, IoT was the hot space last year. Now we're at a completely different way where we're looking at other technology and how to interconnect everything. I will have to admit the technology is nowhere near perfect yet, but companies like Google, Tesla, and others that are following suit are taking this challenge. So to answer your question regarding the managing of data, some of that data will be processed locally on their interconnected devices, which is a lot of things I've been using through apps and your mobile phone, while the larger data, the analytics that will actually make things work, will place new loads requirements on data center.
Well, it's interesting that you mentioned machine learning and specifically deep learning, because on top of storing and managing the data flow, which most people would think of as being what a data center would typically do, you still have to analyze all the information that's coming in, and as you mentioned, that has to be done in real time. And what do you see machine learning and deep learning, the systems that you saw, being the most likely candidate to rise to the challenge, or do you think we're kind of on the cusp of something else where deep learning, machine learning is an entry point into a new level of technology that will handle this information?
You're actually jumping a little too far ahead, and I will tell you why. When you hear my answer, you're going to be quite surprised. The real challenge for autonomous vehicle and infrastructure that we're talking about is really urban city services and solutions that will facilitate the autonomous vehicle viability in the first place. Cities and counties are now forced to look into what we call the smart cities. We do have one city in Silicon Valley that has taken that challenge, and through partnership with the technology sector, the city of Palo Alto is kind of in the heart of Silicon Valley, right next to Stanford, has really put one foot forward, and this is government, who's taken initiative, and what they've done is, the first thing they've done is, just as a test, they converted all of their analog traffic signals to Internet Protocol sensors, which provide more intelligence to help control the network. They then strategically, for example, place sensors to collect data on the roads. And what they're doing is they're trying to solve real-time city problems, which helps drivers, and in the future, the autonomous vehicle, find, for example, parking spaces. What is happening is that the sensors are sending data to a cloud resource to then inform the car of the nearest parking space. Electric vehicle ownership in Silicon Valley is growing very, very fast. But the problem is charging stations. They're becoming an important element of this infrastructure. Therefore, how do you deal with that? There's a forced push by cities, counties, and the state to mandate policies for charging stations. One company that's well known is PlugShare. It's one of the dominant players. They have an app, and it allows the driver to find the nearest charging station. And from several, from my own personal experience, because I have an electric car, they're always full now. So the end result of this challenge is that it forces the city to evaluate and plan future urban development, accounting for the technology change. So that's what we're dealing with. The data center and the infrastructure, it's there, but it's the rest of the ecosystem that needs to follow suit.
And it's interesting, too, the rest of the ecosystem, to me, that talks to the data transmission infrastructure, because it's all good and well to have a cloud that can handle this type of analysis and storage of the information that's coming in. I guess you could look at it as there's only so much bandwidth available for transmitting information. And if we now have hundreds, if not thousands, if not millions of small sensors and devices that are using the same data transmission infrastructure to feed the cloud for all these autonomous vehicles, that would seem to dictate that question of scaling is really going to become very important. So do you think that we're on a timeline where we're going to have to dramatically expand bandwidth availability before we can fully transition to an autonomous vehicle infrastructure?
To answer your question, the current data transmission infrastructure is actually capable of scaling by leaps and bounds. Our existing infrastructure is not 100% yet impacted. However, as more and more complex software is entering the market, solution will have to be developed. What we're doing today is we're actually using mobile phones to drive data center evolution. Hence, the impact is kind of low. But with everything that's evolving, with the autonomous vehicle, if you listen to what I said earlier, it is a huge ecosystem, and all the key players are playing in it to build that infrastructure to be able to make this work. So using mobile phones, sure, it doesn't impact the system, but if we're going to develop that whole ecosystem, we're going to need to have something out there that's a little bit more powerful, and that's where the data center evolution will have to change as well. So as our market is driven by higher demand of these products and services because they're already penetrating the market, what will happen is the performance will be reduced. So we need to increase the performance. At the moment, technology is not an obstacle at all. If you could dream of a process you can implement, just like the success and failure of startups, this is what I see in our center, the core of the autonomous vehicle is actually human behavior. It's how we use the data and analytics to manage and change the human behavior. If you look at global cloud computing marketplace, it is growing so quickly. We're estimating, and if you look at market opportunities, not we, but if you look at what's being estimated right now, $80 billion by the end of just this year. That's a huge market, which tells us that computer intelligence is getting better and better every day. There are more products and services that are getting pushed very, very quickly to allow us to expand into many industries, including medicine and science, every home of human endeavor. Basically, we're revolutionizing the human-machine interaction. So it's not only the autonomous vehicle and its peripheral ecosystem that is leveraging on the infrastructure. Based on what I see in here, it will be a gradual growth in this sector over the next few years. And if you listen to what Google is telling us, because they're pushing very hard, if you listen to Tesla, although we did have one accident, but we're going to have many more because we're learning and we're going to have to learn until we get it perfect. They want to bring this out to the market in the next 2 or 3 years. You could just imagine what's going to happen on the data center side. So I hope I answered your question.
Sara, you very much did, and this has been a fascinating conversation. Thank you very much for taking the time to speak with us today.
Thank you as well.
You're listening to a vExchanged podcast.